The final piece of the cross slide setup is the carriage casting. This is the top of the apron. And this is what the part looks like. That's almost exactly the scale here. That's pretty good. They did a good job on that. What I plan to do, I will modify this slightly from what's on the print. And the print has the dovetail base at the same height as the sides casting. And I'm just not a big fan of that because on a real machine, you can see that the dovetail area is higher and it's troughed on either side. I have to believe that that is for fluid, liquid that flows down. It flows down and just reduces the buildup or the chance of it going in. So front and rear, I'm going to do exactly this. I am going to trough this thing out, make it look a little bit more realistic. If you're going to go outside the print, outside the boundaries of the drawing, outside the boundaries of the model, make sure that you're not going to hurt something else. So my 125 height will be for the dovetail area. The outsides will be slightly lower than that because I just don't want it all on the same height. And I'll have a small canal on either side. I'm going to put the canal in such that this guy right here, when it runs back and forth, will be the same width as the remaining material. That is the plan. First place to start is with a flat bottom. I'm going to rub this briskly across some files and some emery and get it to sit flat so I can start the work. Let's do it. After making sure the bottom of this component is nice and flat by rubbing it on some emery and using files, first thing I'm going to do is remove the draft from the leading and trailing edges of this carriage component. I know I want to squeeze it sideways, and I need a couple of parallel surfaces to do that. Now flip it over and do the other side. And when I'm sure that I have both sides cleaned up sufficiently, we'll go back over to the bench and check the height of these guys for symmetry to the center rib on this casting. The only way to do that is to mark one side with a little dot so I know which side is which when I measure it. Pop it back in for a final adjustment, a couple of thousandths off one side, and away we go. Clean the burrs off of it, of course. Set some parallels up and squeeze it as such. Nice and gentle. You don't want to crown this piece or distort it in any way, shape, or form. Seat it against the parallels. Check the parallels for stability. Load a new cutter in and let's start decking everything down to the 218 on the print. Now later on in the video, you'll know that this top surface should either A, not be touched at all, or only be mildly referenced, but I wanted to cut it off the top. I was very pleased with the way the bottom came out, so I did everything from the top down, but the print calls for the bottom up, and there's a really good reason for that that you'll see about 15 minutes from now. Strictly for convenience and to keep your tooling purchases to a minimum, this is the 075 two-flute cutter that I used to cut the slots in the faceplate. This particular operation is going to cut those coolant troughs in that I pointed out in the very beginning of the video, and it will establish the material
underneath the dovetail contact surface to the same width as the cross slide component. You can see everything starting to look like it's actually going to come together. And for my finish cut, strictly for cosmetics, I always use some coolant just to keep the cutter from packing up, and it gives a better cosmetic finish for sure.
This particular cut will form the surface where the dials will rest and the major V dimension on the dovetail. I'm going to go for a 494 here, and hopefully the feature that I'm going to create right now will act as a break edge on the sharp upper corners of the dovetail.
I am currently machining off the gate that was used to create this piece during the casting process, and that gate runs into a draft surface. So you'll see the clean material migrate vertically as this cut progresses. This is an X-axis camera shot, and I am on the right-hand side of the machine behind the vise. So I'm just looking for a nice clean face, because when I rest my dials on there, I want everything to sit nice and square against that face. I think that's about perfect right there, so just leave well enough alone. The 494 I spoke of before is the dimension across the tips of the male dovetail feature, and that's what I want to create right here. The gauge point is called out as 500, but instead of putting a 45-degree chamfer tool in there or some other tool to break that edge, just start off with a thinner dovetail. It's not going to impact the fit, form, or function of that dovetail at all. And walk it back and forth until you're happy with what you got. Naturally, I'm staring at a digital readout, so I'm cheating here. I know what my numbers are based on the radius of my cutter. And off we go.
Let's do some dovetails, 125 deep.
Either side of this carriage upper is currently at 130 down from the top of the upper surface where I'm drawing that line. Now, anyone will tell you the most accurate way to create a feature reference to another feature is to create both features with the same tool. So what I'm going to do is I'm going to fire up the spindle, and I'm going to scuff that black Sharpie off the top surface. And I know that I will be within a couple of tenths. This is just a piece of Post-it paper. As soon as this starts to shred, I know I'm within 3 thou. Let's renew the black from the abrasion of the paper. And when the black goes away, I'm right there. Ideally, dust the entire top surface off as soon as you see a witness mark against the black Sharpie. I'm going to move it down 125. I'm going to start cutting the dovetail. Now the bottom of this dovetail cutter is going to be 5 thousandths above the surfaces that are secured in the vise, and that is by design. Just for this purpose. I didn't want to leave any scuff marks, scars, remnants of this particular operation on those surfaces after the fact. And having already done this in demonstration in a previous video, I'm fairly confident at the numbers that I'm looking to hit. Do be careful if you're going to rough and finish in an operation like this. If you are staying away from your Z-axis, and you have a very mild dovetail angle on your cutter, you could get yourself in some trouble by doing that, so be very careful. It is best to go right to depth and creep in on the y-axis cuts. Now, after you're pretty sure that you've hit the numbers that you've calculated for your gauge pins, make sure that all the burrs are off of it, all the debris is gone, and that the corners of the male dovetail that you've just created have more of a radius than the inner corners of the female dovetail that you've cut. This is huge as far as making a successful dovetail. If these corners right now that I'm hitting this emery with are sharper than the inner corners, the inner radius on the female, just by doing that, you can open up a world of hurt on the fit that you think you have achieved, and you'll be very disappointed with the slop of everything. So be extremely careful and know your tooling. And drum roll, please. Oh, yeah. That upper corner is so important. Do not let that get in the way. There may only be a 5 thou difference between the bottom of that compound or cross slide and the top of this carriage, but that 5 thousandths is going to feel like a mile when you break those corners off, and this thing is just slopping all over the place. So make sure that corner's got a sufficient break edge. You'll be glad you did. The front of the carriage is suspended from the top of the carriage, and these are the mounting holes that will hold the panel that holds all the levers that control all the gears and half nuts, yada yada yada. But it's got to be done. And while you're in such a perfect orientation and you have a center line established, this is the ideal time to do those features. I am making sure that the drill is not going to hit the parallel before I proceed through this. And if you borrow parallels or have seen some parallels in some shops, you'll know that not a lot of people think that far ahead. But I've hit my parallels one time in 22 years, and I'm very proud of that. But this one was squeaky tight. All right, shift over. I'm going to put the end mill back in the drill chuck. I hate doing it, but this material is so soft, and why not? This is the counter bore for the head of the screw. And as soon as you do both sides, you're done.
Like many engine lathes, the dovetail, or excuse me, the V rail features that the tailstock slides on pass under the carriage. So the carriage needs to be cleared out in the center for those rails. We're going to knock the center out. The casting is pretty much to print, so we are just going to blend from the inside of each one of these surfaces and take this center surface 70 down. That's about 1 3/4 millimeter. This is the fixture that I used for the faceplate machining. And if you watch that video, you know those are the index holes for the different slots. And on the back of this plate, I cut myself a slot. to the same size as the carriage with the pins. So now I have a vertical reference that I can project the pins out of the end. Sweep across the pins with an indicator, pick up all the faces that I need to pick up to machine. And away we go. Gives me my perpendicular reference. It's nice and tight. Well, it's not tight, but it fits really well. So I'll keep this in the box of fixtures with the job. Let's set it up and finish this part. Looking forward to seeing it. We are comfortably nested in the back side of the faceplate fixture. I'm going to bank off of the top of the 125 dovetail feature, move down the 094 on the print because there's nothing modified here. This is done by the numbers. Then I'm going to sweep these two 126 pins I used to create that dovetail to find the X center. Let's do it. Now the print does call for a spot face right here, but the spot face is only to correct the draft from the casting. That has already been machined off, as you can see, is nice and flat. So I'm not going to put that spot face on, but I am going to add a couple of small locator dowel holes. To aid in the installation of the dial. A little dial is going to be harder to do than you would think. One side's got to rotate and one side's going to stand still. And it's got to look good. Minus 8 and plus 5, 13. 6 and change. That's close enough. Snug everything up. Going to ream a 126 hole in this for the 540 left-hand lead screw. The next feature that I'm going to do is not on the print. These are the anti-rotation pins for the dials that I'm going to put on. They're going to be 1/16 diameter, and these holes are about 70 thousandths below the 094 cross hole and about 150 each way off center. I'm going to over drill it as far as depth is concerned. That way I can ream at the depth and not worry about packing chips in the bottom of the hole with the reamer. And wherever you place these holes, make sure that when you place the dial over top of these holes that the dial covers the holes completely.
This naturally is for the side of the dial mechanism that has the index mark on it and will not rotate. The outside dial will be driven by the square right behind the crank handle, and that one will rotate. So we want to go for authenticity here, and this is the price.
All right, now I got to flip it over, put a spot face on the inside. All right, this is where you pay the piper. Every one of these castings has got some kind of home reference point, and it really doesn't tell you what's up. So when I decided to wipe this back off, let's see if we can lock that focus. When I decided to wipe the back off, instead of remove the material from the back because I liked how flat it was, this is where it comes up and bites you in the keister. This is the lead screw channel right here, and you can see that it is just dragging the bottom of that particular cast feature. There is no way the lead screw is going to go in there because it's got a 156 collar on it, and the bottom of this needs to be spot faced out to 156. Well, I'm thinking that I'm going to have to use like a 250 cutter or 187 and go down in there and clean that up, because that's just not pretty. There you go. Got to take a little bit more material out of the bottom of this, make it worthwhile. Now bear in mind, once the dials go on, once the crank goes on, the screw that retains the crank to the entire stack will keep the lead screw from pushing through as such. Oh, I just couldn't be any happier with that. That is just a thing of beauty. My little troughs worked out very well. Right where they should be. And we will revisit this piece once the dials start fabricating, and once the dovetails. I'm going to try to do all the dovetails all at the same time so everything matches. That's the only reason I didn't cut them in this time. There you go. Now, in all fairness, I think I need to confess that the brass dial that is on there is strictly a development slug. Just to take up the extra space I left on the lead screw. The back half will be pinned to the carriage upper, so it's stationary, and the front half will be driven by the same square that drives the handle. Everything should cinch up fairly tight and spin freely. It will be graduated upon completion. I'm going to modify my rotary indexer for that particular video. Quick and dirty. And if you're a follower of mine on Instagram, chances are you've already got a look at this. I am extremely pleased with how this is coming out. Let me say we test fire that screw, huh? Let's do it. A wise man once said, "A thing of beauty is a joy forever." I think that applies. I like it. Thanks for watching, guys. I really do appreciate your time. Joe Pye, Advanced Innovations in Austin, Texas. I'm out.